Alright, we're going to talk a little bit about rules of exponents and how we can use these exponent rules to simplify expressions. So, here are the most basic rules we're going to end up looking at. Let's go like x to the a times x to the b is x to the a plus b. X to the a divided by x to the b is x to the a minus b. What else we got? Okay, we got x to the a raised to the b power is x to the a times b. And then we got, let's say we're talking about, negative exponents as well. For example, x to the fourth is equal to 1 over x to the negative 4. Another example, let's say like 1 over x to the negative 4 is equal to, well, we move that up across the divide and we got x to the fourth. I think if you wrote it down as a rule, right, you'd have like x to the a equals 1 over x to the negative a. 1 over x to the a equals x to the negative a. Oh man, that's brutal. You can memorize all these, but at the same time, you can know enough about exponents and how they behave to where you don't have to memorize them. So let's go through some problems. Oh yeah, hey, one other thing. We've done some problems where we have like I don't know, let's say 10 to the 4/5. Let's go fourth. We'll go 4/3. We need to realize that we can write 10 to the 4/3 as 10 to the 4th to the 1/3. Or you can write it as 10 to the 1/3 to the 4th. Just two ways to write it, and you're like, well, why would I care? Let's say you didn't have a calculator and you're working on getting a good estimation on what 10 to the 4/3 was. Well, you say, okay, well, if I do it this way, I gotta do 10 to the 4th first. Oh man, I got 1, maybe wasn't a great example. 4 zeros. 2, 3, 4. Oh, 10,000. And like 10,000 to the 1/3 power. Oh, that's kind of brutal. What if you did it this route first, right? 10 to the 1/3. That means what multiplied by itself 3 times is 10. Okay, 10 to the 1/3 is between what two numbers? Well, between 2 and 3, because 2 cubed is 8 and 3 cubed is 27. You'll notice, if you look at 8 and 27, 10 is between them. So it's kind of nice, like, hey, 10 to the 1/3, we'll do it in green. No, we won't. That won't show up. Alright, 10 to the 1/3 is between 2 and 3. Right? So if you take between 2 and 3 and you raise it to, the 4th power, that means your answer is going to be between, 2 to the 4th is, let's see, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the 4th. Alright, it's 12:08 a.m. So let's see if I can do 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is, what do we got, 81? Tell me I just did 3 to the 4th correctly. Yeah, it would have been smarter to go like 3 to the 4th is like 3 squared times 3 squared. 3 squared is 9, 3 squared is 9, 9 times 9 is definitely 81. So anyways, hey, I don't know how happy you're going to be, but, we know, right now that 10 to the 4/3 is between 16 and 81. Like, oh, great, that seems really accurate, but not really. Well, if you compare it to the other way, let's say you were doing an estimation, The first thing we did was the 10 to the 4th, so we had our 10,000. So we're looking for the, oh man, the cubed root of 10,000. So what times itself 3 times is going to equal 10,000? Oh man. Okay, well, let's try to get like a lower bound. Let's try to get close to 10,000, but stay underneath it. So I don't know, pick 10, right? Well, it's obviously not a 10, but so 10 times 10 is 100 times 10 is 1,000. Okay, well, 10 cubed isn't very close to 10,000. What about 20, right? Try 20. 20 times 20 times 20. So you got 2 times 2 is 4, times 2 is 8, and you got 3 zeros, right? Hey, that's not so bad, right? 8,000. 8,000. Well, already, like 20 compared to the 16 we found is better. Let's try 30, right? 30. 3 times 3 is 9, times 3 is 27, so 27, 0, 0, 0. Oh man, so 30 is like way above, right? 30 is way above. So definitely the cube root of 10,000 is between 20 and 30. We know that, but we can do better than that. And you could, let's see, you could do some like let's say like 25, right? Let's go 25 times 25 times 25. Right. So 25 times 25 times 25. Oh man, right? So if you get like, let's try to do this, 25 times 25. Oh man, so let's go like, let's think about an easy way to do this. Alright, I got 20 groups of 25. 20 groups of 25. Plus 5 more groups of 25. I mean, that's the first two, right? So that would cover these two. So 20 groups of 25, 2 times 25 is 50. 50 plus a 0. 5 times 25 is, what, $1.25? Oh, so you got 625. Times another 25. Oh no. We can do this. We're not quitters. We're not going to stop. 625 times 25. Oh, alright, we can do this. 625 times 20 plus another, oh man, this could be bad. 5 groups is 625. There's got to be a better way to do this one. Okay, 2 times 625 is, let's see, so 2 and 625, that's 1250 and add a 0. 12,500 plus something, right? 12,500. Well, hey, look, the answer is already over 10,000, right? So 25 is an upper estimate, right? So we actually know, the answer here, the numbers that you're going to put here, number, like they're all the same number, they're going to be between 20 and 25. Well, so between 20 and 25, well, if we compare that to what we had previously, between 20 and 25, or we said our final answer was going to be between 16 and 81. Okay, the 20 and 25 answer, that narrows it down more. So just, I guess that was kind of silly to take you through all that, but I really want you to see that, hey, this can be done, different ways. So you need to know how you can rewrite a fractional exponent, and how you have the option on doing the, the fractional part first, like the 1/3, or the non-fractional part first, like the 1/4.